Hello, I'm Mr. Clark, and in this video we're going to look at Hess's law cycles using enthalpies of formation. So, we're going to have a look at one of the worksheets you have, Hess law calculations, and it's number 4 from that worksheet. We're going to calculate the enthalpy change for the reaction, where we've got 2 lots of sodium nitrate decomposing to 2 lots of sodium nitrite and oxygen. We need to work out the enthalpy change for this reaction here. So when you're using formation data, what we're going to do to begin with is just write down the bottom all of the elements in their standard states. So sodium, nitrogen and oxygen. Might as well just balance that. So we've got 2 sodiums, 2 nitrogens and 3 lots of oxygen. So to construct the Hess's law cycle we need to put some arrows in, and we're given enthalpies of formation data. So formation is where an element is 1 mole of a compound is formed from its constituent elements in their standard states. So when we do formation arrows go up. They go from the constituent element to the compound. A good way to remember this is that you build the house up, but you burn the house down. So when you use formation, the arrows go up, and when you use enthalpies of combustion, the arrows go down. So let's do that there. The next thing I like to do is just arbitrarily assign some algebra. So let's call this delta H1, delta H2 and delta H3. Doesn't really matter your order, but it just helps you write an equation for the cycle. The next thing is let's put in some of the data. So we can see that here the forming of sodium nitrate has this value, minus 468, but there's 2 lots of it, so we could just write 2 times minus 468 here, and over here the formation of sodium nitrite is minus 359, and there's 2 lots of it, so we can do minus 2 times minus 359 there. I'm not going to include oxygen because oxygen is already in its standard state and elemental form there, so oxygen can't be formed from oxygen. There's no value associated with that, so it's just 0, so we just ignore it. The next thing, let's have a look at just writing an equation. So with Hess's law, the energy change for the reaction is the total energy change for the reaction is the same regardless of the route taken. So just follow the arrows. So this arrow is going that way, that arrow is going that way, so that plus that must equal the arrow opposing it, so that summation of that plus that must equal this way. So I am just going to take those values and write an equation. So I have delta H1 plus delta H3 equals delta H2. All I've done is just plug in that way plus that way equals the other way. Now let's take some of the numbers and substitute those in. So we have delta H1 plus 2 times minus 468 equals 2 times minus 359. Let's cancel those down a bit. So minus 936 and minus 718. So delta H1 plus minus 936. So plus a minus is a minus. So to get delta H1 on its own, we're going to add 936 to both sides, and that's going to give us that the enthalpy change of this reaction is plus 218 kilojoules per mole. Okay, and that is how you do a Hess law cycle using formation data. Thank you. Bye bye.